Welcome back to Rust Coding Challenges. Today it's a real classic, best time to buy and sell stock, lead code 121. You're given the daily prices of a stock and you may buy on one day and sell on a later day. The goal is the biggest possible profit from a single trade. The obvious answer checks every pair of days, which is quadratic, order n squared, but there is a much cleaner way, a single left to right pass, order n. Let's build it in Rust and run it. Here's the setup is that we get an array of daily prices and we're allowed exactly one transaction, the buy on some day, then sell on a strictly later day. We want the maximum profit, and if prices only ever fall, so no trade makes money, we return 0. The brute force idea is to try every buy day against every later sell day and keep the best, but that's order and squared comparisons, and it keeps rechecking the same prices over and over. We can do the whole thing in a single pass instead. Here is the idea in a picture. We sweep left to right through the prices. Number 7, 1, 5, 3, 6, 4. Keeping just one number, the cheapest price we've seen so far. At each day we ask a simple question. If I sold today, having bought at that cheapest day behind me, what would my profit be? And we keep the best answer we ever see. The cheapest so far drops to 1 on day 2, and when we reach 6, 6 minus 1 is 5, the biggest profit in the whole array. Buy at 1, sell at 6, profit 5. Let's build it. The signature says it all. Max profit takes a slice of prices and returns an I32, the best profit. Inside we track just two numbers. Min price, the cheapest day we've seen, which starts at the maximum possible integer, so the very first price always beats it, and best, the best profit so far, starting at 0. The body's empty for now, and below it a main that runs a few examples. Now let's fill it in. Here is the whole algorithm. One loop over the prices. For each price we ask, is this a new low? If it is, we update min price because we've found a cheaper day to have bought. Otherwise we check whether selling today, price minus that cheapest price, beats our best so far, and if it does, we record it. After the loop, best is the answer. That's it. A single pass, order and time, and only two variables, so order one extra space. No nested loops, no rescanning. Let's run it. On the price is 7, 1, 5, 3, 6, 4. It prints a max profit of 5. Buy at 1, sell at 6, exactly what we expected. The edge cases check out too. A strictly descending series gives 0 because you're never forced to sell at a loss, and an empty list also gives 0. One clean pass, correct on every case. Why does this work? The key insight is that the best day to have bought, for any day you might sell on, is simply the cheapest day anywhere behind you. So that one running minimum is all you ever need to compare against. At each step, the best profit is just the best we already had, or today's price minus that minimum, whichever is larger. Because we walk the array only once and keep two numbers, it's linear time and constant space. And if prices only fall, best never leaves 0. We're never forced into a losing trade. Quick recap, we track two things, the minimum price so far and the best profit so far. We make one left to right pass, and at each day we compare and update. That's order and time and order one space, which beats the naive order and squared per check by a mile. And the whole trick is a greedy one. The best day to buy is always the cheapest day behind you, so a single running minimum solves the entire problem. A quick note, breaking these algorithms down in Rust line by line takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next one. Thank you. That's best time to buy and sell stock. One greedy pass that tracks the cheapest day behind you and the best profit ahead of you in linear time. Subscribe so you don't miss the next challenge. Tell me in the comments which problem to break down next, and I'll see you there.